Hello, math fans. Mr. Chu here. Let's work a couple more SAT review problems. So this is called Video 8 in my Module 3 that I've been working on. And a module is just like a practice test. It's been released by the College Board for review. I've done Module 1 and 2 already. They had 27 total problems in each. And I'm almost finished with 3 now. So make sure you look at these and get an idea of possible problems that could be on the test. Some problems might be easier for you and some might be harder. And I have to say that one of today's problems has lots of steps and it seems to be a little bit harder for students. You need background knowledge in algebra, geometry, and other math classes that you've taken in high school up before taking the SAT. The topics vary from question to question, and I do not separate them based on their topics. I just list them in the order that the College Board put them in the modules. Make sure you like this video. If it's helpful, follow me on TikTok, Instagram, Facebook, and X, and you'll find more math help videos and announcements of coming things to help you in math. Make sure you subscribe to my YouTube channel. Here's the long link if you want to put it in a browser. There are also links where you can click on to subscribe. If you need to send me an email, whether you want to request a video or just ask a math question, I have an email address, askmrchu@gmail.com. All right, so let's get started. We do have um, a very, very long problem. And this one isn't quite as bad as the second one, but this one takes a lot of steps. There's just a lot of steps in this problem. So it says we've got this graph. The rational function f is defined by an equation in the form of, and it has f of x equals, it is a rational, a over x plus b. A and b are constants. The partial graph of y equals f of x is shown. So this is just part of the graph. If g of x equals f of x plus 4, which equation could define function g? So I take several steps just to find out what a and b are, and then you have to plug in f of x plus 4 to find g of x. Lots of steps. So let's just get started with it. We have to always start out a long problem like this thinking about what is given. So we're given that it is a rational. The function is defined by the rational f of x equals a over x plus b. And we know that y equals f of x is partially graphed there. And then I want to substitute y for f of x. So I can say that y equals a over x plus b. All right. So we're going to find an integer point that the graph passes through. And the first one and the easiest one to see right away would be this point right here. I just highlighted it in red. That is an integer point. We want integer points because we're substituting them in and then doing the algebra. So what is that point? That would be what? -7, -2, I believe. Yep. So I substitute that in. So that's what I want to do. I want to substitute that in. So I'm going to take the x and put a -7 in right here. And then the y and put a -2. All right. So when I do that, I get -2 equals a over -7 plus b. And then I'm going to multiply both sides by -7 plus b because I need to get rid of this and solve for a. All right, so I multiply the left by -7 plus b. So remember, using the multiplication property of equality, I multiply the right by -7 plus b over 1. Why do I put it over 1? because I need to cancel out what is in the denominator on the left. I'll put parentheses around it. So I'm going to take this quantity right here, this quantity right here, and it ends up canceling. And then I'm going to get A here on the right. So what am I going to do on the left? I have to do what's called the distributive property. So it's -2 times -7, which is positive 14. -2 times positive b is -2b, and that equals A. We will use that later on, but not right here at this time. Now we're going to find another integer. Is there another one that stands out? Yes, there is. What about right here? See how that is at an integer intersection? What would that be? -5, -6, I believe. If I counted right. So I substitute that into that same equation, y equals A over x plus b. And when I substitute the x is a -5, the y is a -6, I get -6 equals A over -5 plus b. Just like I did up there, I multiply both sides by -5 plus b. Remember what we did here. This is a quantity in the denominator. This is a quantity in the numerator, and they cancel out. So I'm going to have A, and then I'm going to have to do the distributive property here and here whenever I'm simplifying that. So I get positive 30 minus 6b equals A, and then I'm going to substitute 14 minus 2b for A. I'm going to move my picture up over onto the graph because we don't really need the graph right now. So when I substitute that in, I am going to get the 30 minus 6b equals 14 minus 2b. I just put that in where the A was. I grabbed that from up here where we solved that up here on the 5th bullet. So now I'm going to solve using inverse operations. So I'm going to do them both on the same line because there's so many steps I ran out of room. So I'm going to add 6b to move this 6b to this side because that's a smaller variable. I'm going to subtract 14 from both sides. So I'm using the addition property of equality and the subtraction property of equality. And what happens? Well, this minus 6b plus 6b is gone, and 30 minus 14 is 16. And the 14 minus 14 is gone, and -2b plus 6b is 4b. Now I need to solve this using inverse operations, so I use the division property of equality. Divide both sides by 4. So 16 divided by 4 is 4, and these cancel. So 4 equals b is my value of b. All right. So now we're going to have to find a value of a. How would we do that? We substitute 4 equals b, which is what I just found here, into this same equation we used up here, 14 minus 2b equals a. So I'm going to put a 4 right here where this b is. That's what I did there. And then I'm going to take 14 minus 2 times 4 is 8. So 14 minus 8 equals a, and 14 minus 8 is 6. A is 6. So now what do you think we can do? Well, if we know that b is 4 and a is 6, now I can substitute those into our original f of x equals a over x plus b. So it ends up being f of x equals 6 over x plus 4. Now you're saying, okay, now what do I do? Now I got to look at my g of x because that equals f of x plus 4. So what am I going to do? Wherever there's an x for the f of x, I'm going to put x plus 4 here. Wherever there's an x here, I'm going to put x plus 4 here. So f of x plus 4 equals 6 over, here's my f of x, which is x plus 4 now, plus 4. On the bottom there, that's going to be 6 over x plus 8, and that happens to be g of x, which is choice C. G of x equals 6 over x plus 8. I told you it was a long problem. Lots of steps, just 10.5 minutes for that problem. All right, so now let's go to problem 25. So 25 is not as long, but it still takes up this whole screen. That's why I just put one on each screen. It says, which expression is equivalent to y plus 12 over x minus 8 plus y times the quantity x minus 8 over x squared y minus 8xy. Okay, so the first thing you have to do is you have to find a common denominator, and it would be a least common denominator, and then figure out which one that is after you factor it, or not, you're not factoring it, you're combining like terms, what you're doing. All right, so the first thing I have to do is factor the GCF from the denominator of the second rational expression. So I need to factor the GCF out and then see if there's anything in common in the two rational denominators to see if I could get a least common denominator instead of just a common denominator. So I can take that equation and I can factor a GCF out of this x squared y minus 8xy. And I do have videos on my YouTube channel explaining how you factor the GCF. It ends up being xy times x minus 8. You're actually reversing distributive property. So if you look, I've got an x minus 8 here, I got an x minus 8 here, but this first one is lacking the xy. So I'm going to have to find a common denominator by multiplying both sides by xy, or not both sides, that first fraction, sorry, by xy over xy, because what is xy over xy? That's what, when I was teaching in brick and mortar, I would call that a special one, because it equals 1, because anything over itself equals 1. So if I multiply a fraction by 1, I get that same fraction back. It's just not in simplified form. So I'm going to take and multiply this first one by xy over xy. And when I do that, look what's going to happen. The distributive property is going to give me the same thing here. And then I'm going to have to use the distributive property up there in the top. So it's going to be xy times y plus xy times 12. And then this is going to be y times x. And then y times minus 8. So when I do that, I end up getting x squared y plus 12xy over x squared y minus 8xy plus xy minus 8y over x squared y minus 8xy. I took and did the distributive property here. Distributive property here. Distributive property here. And now I'm going to add the numerators. So I'm going to take this numerator plus this numerator because the denominators are the same. And that is called a common denominator when the denominators are the same, and you're able to add the numerators. So when I do that, I end up getting x squared y plus 12xy plus xy minus 8 over x squared y minus 8xy. It's the common denominator. Then I'm going to combine like terms because I've got 12xy and xy here. And that ends up being x squared y plus 13xy minus 8 over x squared y minus 8xy. And that happens to be choice C again. So both of these were choice C's. All right. So make sure you follow me because it's important that you follow me. It allows me to push my videos out to more people, get involved and help more. struggling math students. Also, I will be announcing on TikTok, Facebook, Instagram, and X about some upcoming events. What is a big upcoming event? In a couple of months, whenever the classes start for the new school year, I'm going to be offering a free um, weekly Zoom meeting to help tutor students that have questions. And it doesn't cost anything. You'll be able to come and ask me questions. We'll work problems. I will have 5 different problems that I will work each time, and you'll be able to email me and get these to see what we're going to work on. And then you can come and ask any questions for anything that you may need help on. So remember, there's 27 problems from Module 1 and 2 that have already been worked in the playlist on my YouTube channel. That's why it's important that you subscribe to my YouTube channel. And then I do have an email address, askmrchu@gmail.com. You can ask me any math question, and I'll do my best to answer it. And that may include you requesting a particular type of video, and then I would either reply in an email and tell you that I couldn't do it right now, or I was going to do it, or I might be able to answer your question in the email. So help spread the word that Mr. Chu wants to help people with math. I'm a math teacher. I retired from the classroom, but I want to keep helping, and that's what I want to do is help you. I have a curriculum that's my algebra videos. It's called Bear Algebra, named after my 13-year-old peekaboo. And then I've got Brack Geometry as my geometry curriculum, named after my 3-year-old Italian sheepdog, and he weighs 120 pounds. And then I have Tray Arithmetic and Pre-Algebra that's named after my 4-year-old black tomcat that often jumps up on my lap and wants to rub against my head and put his tail on here during some of my videos. So just keep an eye out for Trey as he jumps across the screen. I also have something called Math Minutes that I will be posting just a couple quick problems that you can work on different topics on my YouTube channel. And then I have these problems, which are the SAT prep problems that people can work on. I don't know why that keeps blinking off and on. Oh, it's because they're both highlighted together. So why? There we go. So I'll see you in the next video. And remember, this is important. I'm Mr. Chu, wearing my Indiana hat because I live in the state of Indiana. And I want to help you understand math. Subscribe to my channel. Check me out on the social media. And I'll see you in my next math video. Mr. Chu out. See you next time.